Okay, this is going to be pure 1 in hopefully 9 minutes. Okay, off we go. Right then, so algebra expressions. First of all, what do you know? You know anything to the power of 0 is 1. You know 1 over x to the power of a is x to the power of negative a. X to the power of 1 over n is the nth root of that number. Okay? Something that we always forget, but we need to know, is if we multiply with the same base, we actually add. And a lot of the time, I know we see it this way, but we always go backwards. Okay? Sometimes they do it backwards. That's exactly the same with dividing. We actually take them away. When we raise to the power, x to the power of n, we multiply. Okay? Surds, when we manipulate them, make sure that you're happy going forwards and backwards. Root a times root b is square root of ab. Rationalising the denominator. If you had over root a plus b, we're going to multiply by root a minus b, root a minus b, because this is essentially multiplying by 1. Okay, chapter 2, quadratics. First of all, get your calculator. Make sure you always write your ABC, okay? And quadratics are always ax squared plus bx plus c equals 0. You can solve it using your calculator or using the quadratic formula. Completing the square, always remember if the coefficient is 1, so this number in front of the x squared is 1, you're going to get x plus b over 2 squared minus b over 2 all squared plus c. If the coefficient is not 1, so it could be negative 1 or it could be 2, okay? If this coefficient is not 1, you need to divide everything by a. So you're going to get ax squared divided by a plus bx and then divide it by a plus c and divide it by a. From there, what's going to happen is your a's are going to cancel and then you can carry on with how we normally complete the square. Next up, we have the discriminant. Discriminant is b squared minus 4ac. Okay, that tells us whether a graph has no solutions. The graph is going to be up here somewhere, okay? It doesn't cross the x-axis. And this is when b squared minus 4ac is less than 0. It has 2 solutions. This is when it is greater than 0. And then some people like to call this, you can see here it has 1 solution or equal roots. This is when it equals 0. Okay? The skills for the discriminant are easy. Figuring out when to use a discriminant, that's what's sometimes hard in the questions. Okay, chapter 3, equations and inequalities. First of all, everyone should be happy with simultaneous equations, okay? If you had x plus y equals 6 and you have x squared plus y squared equals 10, rearrange the first one to get x or y equals, then substitute, expand, etc. We should all be happy with that. Now, when shading graphs, sometimes it will ask us to shade a graph. If you have a quadratic equation, plus 4x plus 5 is less than 0, okay? It's less than 0, we shade below the graph, okay? So the graph is going to look like this. If it's less than 0, we shade anything below the graph. If it's greater than 0, above. This is the same for a straight line. If I have a straight line, y equals mx plus c. So if mx plus c is greater than, what do? We shade above the line. If it's less than, we shade below the line. Then what we have is when it tells us, right, we've got these 2 lines and they do not intersect. If lines do not intersect, or they do intersect, okay, and it says find the range of values, okay, you have to put them equal to each other, then that is when we do the discriminant, okay? When in doubt, draw it out. When you're doing the discriminant and you've got a positive quadratic that's less than 0, okay, you're going to have 1 inequality. If you have it and it is greater than 0, you're going to have 2 inequalities. K is greater than a number and K is less than a number, okay? Chapter 4, when we are dealing with graphs and transformations. If we have a cubic that's positive and it has 1 solution, it's going to be drawn like this. If it's got two solutions, normally you find when it's drawn, you've got an equal root here. And if it has three solutions, it's going to draw like this. The amount of solutions is how many times it crosses the x-axis. We should all be very happy with that. Now, when you do have a quadratic, remember the y-intercept can be found by multiplying all the integer values together. Okay, because you're going to have x, and then the y-intercept can be found like that. We should be happy solving them. What graphs do you need to know? You need to know y equals 1 over x, looks like this. And it has an asymptote on the line y equals 0. Okay? You need to know 1 over x squared. And this is going to look like this. And we also have an asymptote on the line y equals 0. Now, my favourite part of graphs and transformations. If it's inside the bracket, who does it affect? X. And what do? The opposite. If it's outside the bracket, who does it affect? Y. And what do? We do what it says. Okay, perfect. So, if you had 1 over x plus 2, this is essentially inside the bracket. This is different to the graph of 1 over x plus 2. Okay? 1 over x plus 2 is inside the bracket, so it affects x. If it's on the outside here, this is outside the bracket, essentially. You've got to think, when you put f of x equals 1 over x. F of x plus 2 equals 1 over x plus 2. That's how you know if it's inside or outside. Okay, chapter 5, straight line graphs. Everyone should know this equation. Y equals mx plus 6. How do we find the gradient? y2 minus y1 over x2 minus x1. x1. Okay, if you only need a gradient and a set of coordinates to find the equation of a straight line. That's all you need. If you've got two sets of coordinates, you can find the gradient, and there you go. If the line is parallel, what do we know? The gradient is the same. If the line is perpendicular, okay, it's going to be negative 1 over, okay? Now, the other thing is, when you're dealing with length, do not forget your trusty friend. Who is he? He is Pythagoras, okay? And what else do you need to know? If you're doing area, remember, for any triangle, base times height divided by 2. Area of a triangle, base times height divided by 2, okay? Okay, we're moving on now. We are on chapter 6, trig. Okay, cosine rule, everybody should be happy with, and I think we even get this, do we? A squared equals b squared plus c squared minus 2bc cos of a, okay? Then we have the sine rule. A over sine A equals b over sine B. You could use this as sine A over A equals sine B over B. What else do we need to know? A half AB sine C. This is the area of a triangle. Now, when in doubt, draw it out, okay? If it's telling you, draw it out and then figure it out from there. Now, the other bit in this chapter is transformation of trig graphs, okay? So first of all, you need to know 3 trig graphs. Sine. Everyone should know sine. This is 360 or 2 pi. Okay, this is pi or 180. This is 1 and minus 1. This is our sine graph. Cos cuts. Okay, it cuts halfway through. Okay, it starts here, and it's also a transformation of the sine graph. Remember, this is 270 or 3 pi over 2. Okay, and this one here is pi over 2 or 90. It might ask you. We still have a minimum and maximum of 1 or minus 1. And then last but not least, we have tan. It's just a snake. Okay? We've got our first asymptote on the line, x equals 90. Our next asymptote, 270. Okay, and then it finishes here at 360. When it says how many periods, do you know what a period means? A period means this. Sine is like this. It has one hump and one under hump, hasn't it? This is one period. So if you do a transformation and you end up with two of those in between 0 and 360, you've gone 2 periods, okay? So think a bit like that. Okay, this chapter is really important. Every time you see a trig question or anything like that, read it. If it says degrees, look at your calculator, okay? You want it in degrees or radians. Now, the other thing that you need to know is arc length. If you haven't memorized the formula, it's okay, because you know this is going to be theta over 2 pi, because this is our proportion, times our circumference, which is 2 pi r. What you do need to do is you need to cancel this out before you start substituting in, so that you're just left with theta r. If you remember that, fine. If not, go the old-fashioned way, but do not start putting in numbers in this form. Do you understand? You have to simplify it because people make mistakes. Then we have sector area. Again, you might not remember what it is, but you know the proportion is theta over 2 pi multiplied by area of a circle. Okay, so we're going to multiply that by pi r squared. Now again, we're going to cancel pi. So we're actually going to get a half theta r squared, okay? Now you can use the formulas from there. Now, something to be very careful of. If it asks for the perimeter of a shape, remember, if you've got this perimeter here, I want you to write down, this is r, and then you know this is your arc length. You've got 3 things here. You need to write down what you're going to do. 2r plus theta times r, okay? Show them every step of your working. And the same for area. If you've got a whole circle with a chunk missing out of it, and then an extra part here for some random reason, show them your steps. Draw the shapes separately. So you're going to do this shape first, and then add on this shape, okay? Right, question chapter 8, differentiation. So this is when really you need to know quite a few things. First of all, if you had x to the power of n, what do? You bring the power down and take away 1 from the power. This is how we differentiate. We cannot differentiate if we've got 2 terms over a fraction like this. We need to split it up. So step 1. Split it up and simplify it, and this is from chapter 1, and then move on, okay? Now, we know that when we differentiate, this gives us the gradient of the tangent, okay? This gives us the gradient of the tangent. If we want the gradient of the normal is perpendicular, so the gradient of the normal equals -1 over the gradient of the tangent, just like we know from earlier. Now, the other thing that you need to be made aware of is sometimes it will say to you, you know, you've got these points, the gradient equals 10 when x equals 4. So you can say 10 equals and substitute in 4 everywhere you see an x and then solve it. Okay, because maybe you'll have a plus c here. If you have cx squared and you have to differentiate that, this becomes 2cx. Okay? It's like a problem-solving question. Treat c as a constant. Last chapter is integration. Increase the power by 1 and divide by the new power. So, if you have x to the power of n, you're going to do x to the power of n plus 1 over the new power, n plus 1. Okay? So the integral of this equals this, and what should we always remember? Plus c, our constant of integration. It will then say, find the constant of integration. Find the equation. If you need to find the equation, they'll give you a point, which you can substitute in and find c.